So we're at GemTGS today. This is our first official Google Hangout uh, meetup, so I'm excited about that. And John-David Dalton is going to hang out with us today and talk about Lodash. So John, take it away.
All right, hi. I'm just chilling out in my house before work, but I'll talk about Lodash now. So I created Lodash about 2 years ago, and it is a collection of JavaScript utility methods. How many people are familiar with underscore? All right, so most. All right, good. So Lodash is an underscore alternative. It delivers things like array map, filter, every, reduce. It does things like unique, flatten. It has bind, partial application, curry, and lots of methods. There's more than 100 methods, and the focus of Lodash was to be a better alternative by delivering more consistent and tested methods. So, for example, at the time, and even now, there's a difference between how methods behave in older environments and newer environments. So older browsers would behave one way with an array or an object with underscore, and in the newer browsers they would behave differently. And I thought that was kind of wonky. I thought if you claim to support something, you should support it consistently in all the environments that you work in. So that's what I did, is I made Lodash and I made it work consistently. And then to offset the cost of bug fixes and all these consistency fixes, I had to optimize it. And so performance kind of came out of that, out of optimizing away the cost of bug fixes and all of the consistency stuff, because the more things you put in, the more checks and fixes you put in your code base, the slower it could get. So I had to work and solve those issues and make it fast on top of that. When I released Lodash, I made it. I led with performance, because that kind of gets devs' attentions. If you say like, "Hey, this is up to 8x faster," it gets their ears. But now I've kind of pulled back on that message, because it's more than just performance. It's about consistency. It's about quality, support, customization, and really improving the developer experience with utility methods. So performance is great initially, but I kind of pulled back. And now I haven't stopped a focus on that, but it's now like third on the list of things. It's consistency, it's customization, and all of that. So Lodash is also highly customizable. It's probably one of the most customizable JavaScript libraries out there, and that's because you can create a build of any of the methods you want, and you can even mix and match compatibilities. So you can create a build with the underscore version of one method and the Lodash version of another method, and it would work. And that's crazy complex to get all those parts moving. And so later on, I'll talk about the testing strategy we have for that. But so if you have like npmjs.org pulled up, you can do a search for Lodash -CLI, and that's the custom build utility for Lodash. There's also links to it on lodash.com/custom builds, which is custom-builds. And there's links on the homepage to that too. And that allows you to create builds tailored specifically for the environment you want. So say if you're a fan of AMD, you can get a build that's just AMD. If you're a fan of Node, you can get a build that just works in Node. If you're a fan of CommonJS, like pure CommonJS, like not just the Node flavor of CommonJS, you can get a build for that too. And then we've also offered things like modules too. So in 2.0, which was released in the fall of last year, we modularized everything. So normally Lodash is this big monolithic library, and devs will even though it's like less than 10 kilobytes minified and gzipped and all of that, devs will say, hey, I just want one method out of this utility library. Why do I have to include the whole thing? And so the modularized build allows devs to do that and to consume it in the module loader that they're used to. So if they want to use Node and Browserify, they can do that. If they want to use AMD, they can do that. And there's different forms of it too. So for example, some devs prefer individual NPM packages. Some devs prefer a bundle of modules and using Browserify to just build the modules they require out of this directory of modules, or this package of lots of modules. So we offer that too. One of the things we did to improve performance was to ditch native methods. So how many people would generally assume that native methods are faster than regular JavaScript implementations? If you didn't know Lodash existed. Okay. Well, a lot of devs are surprised by that, that you can get faster than native performance with simplified alternatives, implementations of native methods. So you can get faster than array, map, filter, each, bind, which is function bind, and lots of these APIs. But you have to sacrifice some of the edge cases. But in our case, it actually made things more consistent because older environments, and so when I say that, I mean like IE less than 9, so IE 8, would iterate over arrays differently and consider arrays sparse that other engines didn't. And so by treating all arrays as dense, you end up getting consistent iteration and performance in all environments, which was pretty cool. And I didn't just say like down with native method use. I profiled it. I looked at the signatures of them across the supported browsers, and then made a choice based on the general performance behavior of those methods. So for example, we use object.keys, which is ES5, because it's faster than a for-in loop and has own property checks. But we also back that up by supporting and fixing all the iteration bugs that happen in object.keys. So certain browsers, mobile Safari for one, has bugs with object iteration with object.keys, and so we go through there and fix all of that too. So just because these native methods exist, it doesn't mean they're not buggy. And so there's a lot of little glitches we smooth over. Some of the other things I've done is when I first developed Lodash, I said the key to performance was to reduce abstraction. And so we did things like method template. We use method templates to compile JavaScript functions dynamically to avoid all of these checks for buggy browsers and for browsers that didn't need them. But that kind of made the code hard to parse, like reading it, because you're looking at this text template for a function. So I threw comments at it, and that still didn't smooth it over. So I've moved away from that, and now the actual secret to performance is more abstraction, believe it or not, because JavaScript engines are great at handling small functions. And so moving forward with Lodash 3.0, which I'm very close to finishing, we're held up with documentation, believe it or not, generating the docs. Our old parser was written in PHP, and we needed to port that to JavaScript. And so I would rather do anything than port PHP to JavaScript, so I've been pushing that off. So I finally created a bug bounty for it, and someone actually did the majority of the work. So hopefully we'll be able to finish that up and push out a 3.0. But with 3.0, one of the things I've done is everything that's exposed externally as an API point. So underscore dot each, underscore dot bind, underscore dot whatever. That entry point does all of the things that disable JavaScript optimizations. So if it needs to muck around with an arguments object, like splice it, and only and shorten it or convert it to an array, or do something goofy where the function will disable the optimization, it's a very small piece of the actual thing that's being called. So what happens is that external API then calls into internal optimized functions that don't hit those things that cause it to de-optimize, that don't need to parse an array or an arguments object, that don't need to coerce values from non-numbers to numbers, that don't need to do the try-catch. And so that leaves all of the internal methods optimized, and so they avoid all of those traps. And then other methods can then use them too. So, for example, like _.flatten, the internal form of that is called base flatten, and base flatten is used by lots of other methods, and it avoids the de-opt of the necessary de-opt of the actual external API call. So basically, the external API allows you to do things like pass in NaN, pass in a string instead of a function for a callback, and we'll convert it to a function, or an object and we'll convert it to a function. And it does all of that kind of heavy lifting. And internally, you don't need any of that. Internally, you already know what you're going to get. You know you're going to get a number. You know you're going to get a function. So you don't have to have those checks in place, and it creates optimized code internally. So that's our performance strategy moving forward, is to add more abstraction, smaller functions, no code compilation. So hopefully that's an increase in readability. It's an increase in understanding of the source code too, because there's smaller functions. It does increase the breadcrumb trail, because you have to go from one function to the next function to the next function. But that's okay. You can also, whenever we modularize that, you'll be able to just travel from one module to the next module to the next module. Something else I've learned over this last year is that Node developers will say, hey, we love modules, but it's really, we love modules to a certain point. It's when your dependency graph gets large that people start going, I don't care about modules. And so what we had with Lodash 2.0 was modules modularized individual NPM packages, but each one would then depend on another module, and which would then depend on another module, which would then depend on another module, because that's how modules work. There's a lot of sharing and reuse that goes on, and we had a lot of that, and apparently that caused our dependency graph to kind of explode a bit. So you would require one function, but it would have a dependency graph of like 10 modules. And that wasn't just like some surface issue. It actually became a usability issue, because Windows file path limitations would kick in, and all of a sudden having a large dependency graph hurt Windows users, because the modules they had would fail to load properly, because once you pass that 256 character limit for your path, or whatever that limit happens to be, things start breaking. So moving forward, whenever we modularize the NPM packages, we'll actually remove all dependencies. And to do that, we just inline everything. So it's horrible for code dupe and people that dig modules at heart, but it works for NPM and it works for Node because of the file path limitations. Now that said, we haven't given up on modules. What happens is now, instead of offering the Lodash Node bundle and the Lodash AMD bundle, we're switching that up a bit. So now the primary Lodash module that you npm install Lodash will actually have individual modules within it. So you can then require Lodash/object/isObject and get just the isObject method. So if you're doing browserify, you could just require the individual modules and then create an optimized build whenever you browserify everything up for the compiled end result. Will have just the modules you used instead of the monolithic Lodash library. So you'll still get the benefit of doing it that way. But for NPM, we just noticed that like Gulp was having problems because they depended on a Lodash.template package, which would then explode the dependency graph. So we don't want to do that. That's causing grief. So that's something else that we will do, is basically just inline all the things. And so going forward, I've improved our build to detect unnecessary dependencies and warn me about them, and also it removes them automatically. So on the final release, no end user should see warnings about missing or unnecessary dependencies, because I should have already removed them. But it's handy during development time for me, for the build utility to say, hey, you included these dependencies, but they weren't needed, so we removed them. So we'll be doing that. Something else I'm really I dig about Lodash is the method shortcuts. So most people know you can do array, each, or filter, or map, but you can also, instead of passing it a function, you can pass it a string, and it will act like a pluck. So say you had an array of elements, and you wanted to filter all of the ones that had disabled as being truthy. You could just say every element, and then instead of a callback function, you would just put the property string disabled, and it would do the pluck for you. And so that allows you to write more expressive short code. It's also very similar to the ES6 method shorthand, except, of course, with ES5 and ES3 syntax. So it allows you to do some pretty nifty things. You can also do things like, instead of filtering for a group of object properties, you can pass it the object and the properties you want to match, and it will automatically create the callback for you. And that's been in 2.0 and probably a little bit before 1.0 too. And that's something that Underscore is getting as well. So I haven't been sitting on this code base for 6 months. Every day I do code commits. And I keep up that GitHub streak that I'm on. It's on 360 days at the moment. So woo, almost a year, getting close. But Underscore isn't either. And so they're my primary competitor, but I'm also trying to push them in my direction too, because having two code bases that are similar but different is really tricky for developers, because you'll say, hey, I want my library to work with both Underscore or Lodash, and so having API points that are different causes friction there, and is more work for developers that want to just build on top of something. So I've been pushing them to align more with our API, and in their next release, they're going to be very, very, very much Lodash-like, minus the object iteration and string iteration fixes that we did. So it's kind of like the modern build is more like what they're becoming. They're going to have method shorthands too, like we do, so you can pass a string or an object instead of a callback function. They're going to align with our API in lots of places, where things that didn't allow a callback will allow a callback. So pick and omit methods, we allow a callback, and they're aligning there too. And hopefully they'll align with some of other behavior. It's quite a long list. I think they're going to bump 2.0. So we're bumping 3.0 for our next release, and I think they're going to start following Simver, which is something I've been pushing them to do too. So basically, if you don't follow Simver and you're requiring them in your npm packages, well, since they don't follow Simver and you're requiring them in your npm packages, if you don't reference their version number specifically, if you have a version range like a tilde or a caret or something like that, you're setting yourself up for a fail, because historically they don't follow Simver, which means they'll break compatibility with minor patch updates. And that's a big problem, and that's something that Lodash doesn't do. We follow Simver so devs can rely on it without it breaking. So we usually say, hey, is this a win for devs? We'll do that. So we've been working on that too. With 3.0, I'm kind of talking more about 3.0 because it's so close and there's a lot of cool things. I've been working on it for like 6 months. If you go to the Lodash repo, so GitHub Lodash wiki, there's a changelog there, and you can view the work in progress changelog. It's massive. It's the biggest changelog entries we've had per any release. We're adding 35 more methods. So on top of those 100 methods, take 35 more. Wow! And those methods are string methods, a lot of them. And they're methods for devs that like functional programming. So we added things like trim, left, right, pad, left, right, truncate, escape regex, things to allow camel casing, snake casing, kebab casing. And so those things are like, kebab casing would be like your slugify. So basically, I surveyed the existing string methods from _.string and some of Lodash's competition, and picked the place where they kind of intersected. So as a start for string method support, we would have some of the more common methods for string use. And on top of that, we've optimized them for performance and consistency and all of that jazz. So you know that it's got the same level of like Lodash quality, but now it's included in Lodash. So you'll have all of that. I've also added something like curry write and placeholder support. Placeholder support in partial application is something that is an underappreciated feature, and initially I thought it was kind of who would ever use this, but it's super handy for function composition. What a placeholder allows you to do is skip that argument and allow the user to provide it. So normally when you do partial application, it's from left to right, and there's no way for you to skip or put gaps in the arguments you provide. So if you have to provide like A, B, and C arguments, and then leave D and E for the developer to fill in, but you can't just like skip B. And that's what placeholders allow you to do. It allows you to kind of skip an argument, and that allows for easier function composition. And that's something that we don't support yet, but we will in the next release. And we support it in all methods that allow partial applications. So that means bind, partial write, curry write, all get placeholder support. And then we'll also be adding that for the modules too, because placeholders are tricky once you get into modules and you don't have an underscore namespace available. But that's something that we've worked on. One of the cooler optimizations that Lodash does is we track metadata on the functions that are created when you do a bind or a partial write or a curry write or a bind keys or wrap even. And what that allows us to do is if you try to then use another one of those functions, the ones that I just mentioned, on the function that was already created by one of those functions, it'll create the new version that's still only one function call away from the original function. Because with that metadata, I can then flatten everything down. So no matter how many times you wrap that call, it always flattens itself down into a single function call. And that was really fun to implement. It uses bit masks, which is crazy. I never thought I would have a case to use bit masks, but there's so many configurations and options there that it was necessary. One of the other things I like to do is you'll find use of labels for loops, and you'll see those inside the intersection and difference methods, I believe. So if you're looking for some interesting JavaScript usage, dig through the Lodash source, you'll see some things that you normally don't. I'm also using ES6 methods in the 3.0 release. So large iterations of linear searches for like index of is really where your performance issues happen. So when people talk about, hey, I switched to Lodash and I got this performance boost, they're usually dealing with large arrays, and they're dealing with methods like difference, intersection, unique. And one of the ways we optimize that is to use ES6 set. So ES6 allows you to create a set or a map. In this case, sets contain objects, but they're always unique. And so we just take your large array and we cram it into a set. And it automatically takes care of all of the values to where they're all unique. And so then we push it into the set, and then we just read it out of the set. And that gives you all of your values unique. And so that's how we handle large linear searches, because then you can dig through and find your values faster. And that's very handy. Other than that, got lots of interesting things for you to dig into. On the website there is links to videos, blog posts, screencasts, and lots of things to kind of get your feet wet into utility methods. And also, if you find a bug or something like that, we're pretty easy to get a hold of, and we're really responsive on the fixing the bugs too. If you look at our repo, there's only one active, and that one's really like a long-standing bug. It's actually a feature request to support lazy evaluation, and I'll get to it one day, maybe. It's been there for like a year and a half, 2 years now, so we'll see. But yeah, is there any questions on Lodash?
So I have a question. So if I have like just a couple of methods that I want to use,
Yeah.
you want just those. What's the easiest way to just grab and build like just load after just the things I need?
Okay, so are you using something like Grunt or Gulp or?
Right now we're using one of those two.
Okay, so Lodash provides a grunt task for you to automatically configure the build you want. So you can just configure it with its options and integrate that into your build and your other grunt tasks, and it will generate the Lodash file for you. So you can do it that way, or you can use the Lodash AMD build, which would have all of the methods modularized for you, so you could just pick and choose which modules you want. Or you could use the Lodash node package, which contains all the methods modularized as well. Like I said, in 3.0, the modern build of that will be consumed by the Lodash primary package. The others will be available as like Lodash -_ and Lodash -compat as module bundles. But yeah, you could do that. And if you're feeling lucky, you can use the individual npm methods as well if you're wanting to just pull those in, assuming they don't cause path issues for you. I mean, there's lots of people that use them. The path issue comes up occasionally, so you should be okay generally for that. And then, of course, that'll be resolved in the 3.0. But yeah, there's lots of ways. We originally only offered the build utility, but then devs, that's not part of your workflow. You need something that works with Grunt and Gulp and your package managers, and so that's why we offer things like it's available like for Volo. Well, if you're using AMD, you can use Volo and get the AMD packages. Or it's available on npm as already pre-populated, pre-packaged modules, so you can include those in there too. So I would say it's one of those three should get you where you need to go.
Cool.
Yeah. The build tool also removes things like dead code. It works with aliases. You can say you only want the each method, and it knows that you really mean for each, and it'll include that plus the alias there, and generate the file for you. Something we do, which is crazy cool, is we run your build through 2 minifiers and 4 passes. So we run it through Uglify.js, we run it through Closure Compiler Simple, Closure Compiler Advanced, and then we hybrid them. So then we run it through Uglify plus Simple Closure Compiler, and then Uglify plus Advanced Closure Compiler, and then choose the smallest build and output that for your file. If you want source maps, then of course we only use one minified pass, because source maps get weird if you send it through too many minifiers. But yeah, so that's something else that we kind of do. And I noticed some improvements to the minified file size for that too. So that's why we do it. It's fun.
You mentioned earlier that one of the big performance gains you get with Lodash is that you sort of removed some edge case handling from the native methods.
Yeah.
Could you maybe give an example or two of maybe some of the more common edge cases developers might run into that we might need to consider?
So the primary one for array iteration is the sparse array issue. So normally, so you can create a sparse array. Devs may create them on accident. That's usually how it's presented to me, is like, hey, I switched to Lodash, something broke. And it turns out they had an accidental sparse array in their code, and their code didn't behave the same way. So what happens is in normal ES5 array methods, if you have a sparse array, which is a hole in your array, so if you did like array 3, that creates an array with a length of 3, but no values in there. And so they're called holes, basically. And so normally, native array methods will skip your holes. So if you had keys at 0 and 2, but not at 1, the iteration would go 0, 2, and skip 1. But we don't do that. We treat them as dense arrays. And so we treat the hole as a literal undefined value. So we go 0, 1, but the value of 1 is undefined, and then 2. And that's the thing that devs may stumble on. Now, we're consistent across all environments that way. We treat sparse arrays as dense for every environment. The reason that devs switching from underscore saw this is because they weren't testing in older environments. If they were, they would have run into that issue. They were instead testing in their modern environments first, not seeing the problem, and they weren't going to see it until they tested in the older environment. And then it would be harder to debug, because who wants to debug in an old browser's F12 or something? I mean, like, ooh, it's not fun. So because we're consistent, you run into those things up front in your modern testing environment. But that's the primary edge case for array methods. There's things too that we do that aren't really overhead. They're more usability centered. So for example, we don't throw errors if array reduce will throw an error if you have a length of your array is 0 and no initial value. That's weird. Why throw an error? No one wants to catch these errors. You just want it to silently do what it needs to do. Or like object.keys. If you passed it a number instead of an object, normal JavaScript would throw an error. We just return an empty array because technically that number has no own enumerable properties, right? There's no need to throw an error. So we don't. So we kind of improve the usability there. So even with ES6 methods, ES6 is going to get object.assign, which is like object.extend or underscore.extend for assign. But they will throw errors if one of your source objects is null or undefined, and that's gross. You should just skip it, right? You shouldn't just. You don't need your code trapped with all these try catches or all these conditions to check to make sure you're using the method just right. The method should be forgiving and should allow you to do that. And a lot of times, what you're wanting that behavior. So you can pass string.match to underscore.each, and if the match is null, we don't error. We just don't iterate over the null. But if it does exist, then we'll iterate over the return value of that string.match, which is super handy. And so that's one of the things that we differ on. Other than that, we don't use native function.bind, and that's a shame. I would have loved to use native function.bind. But it's inconsistent from environments that support it to environments that don't support it. And there's no real way to be consistent about it unless you get super hacky, and even then you're not 100%. Bind is one of those functions that is really hard to shim, and there's a lot of these bizarro edge cases. So native bind will create a bound function that has a length property that is equal to the length property of the original function minus anything you partially apply. And setting the length of a function isn't really doable in pre-ES6 environments without using something like a function constructor or a val. And that disqualifies you from being used in a CSP environment, so that's right out, right? We can't do that. So that means the fallback code would be inconsistent. And there's other weird things too, like .apply and .call are poisoned with certain values, and there's no prototype property on a bound function. All of these things are tricky, right? And you'll run into code that actually relies on that stuff. And so to be consistent, we had to ditch function.bind use. Now, it's not so bad because like V8 has a horrible function.bind performance. It's super gross, super slow. But other browsers have a very fast implementation, and I would have loved to use it. But I cited for consistency. And so with Lodash 3.0, we've optimized bind more for very narrow use cases, but it should be an improvement there too. So that's always our struggle, is trying to beat or meet native performance. And just like with these JavaScript array methods, they've been slower than regular JavaScript alternatives for about 9 years, but they're catching up. And they're getting really close. It's becoming super tricky for me to beat them. And it's not obvious the things you have to do to beat them. One of the things I do is, normally you would say, hey, I've got this callback. I need to do a for loop and execute the callback with a this binding. So callback.call, right? Every single time. But many times devs aren't passing that this binding. So you hoist that out of the loop. And only bind the function if it's passed, right? And that gives you super fast execution. So that's how we're able to beat native in many cases, is to just hoist that work outside the loop. And that's where we differ on native behavior. We also, because we don't rely on native, we can have that wiggle room to add those features, like a chaining for _each. Each chains. Native doesn't chain. Reduce accepts a this arg. Native doesn't accept a this arg for reduce or reduce right. We're able to adopt things like object.assigns once it becomes available in the language, because we've aligned our _.assign method with its API enough to where we can use it under the hood without having to introduce back compat breaking changes. I've also done things like opted to use our own implementation of trim, because the spec says that white space is specified on the current version of Unicode at the time of the specification, but that version shifts and changes, right? Which is bad for consistency. Depending on the version of the browser you use, different things are considered white space, and that's gross. Lodash provides you with a reasonably fast implementation. It's faster than Chrome, for example, slower than Firefox, but it's consistent in all environments. And so that's why we do it. We usually side for consistency over performance, and that's where we prioritize things. Consistency for devs, performance is the bonus, and that's how it's always going to be for us. One of the things we do is we optimize for the common case, which is a good strategy regardless of what you're doing. Figure out what your common case is and make sure that your fast path is that case. Make sure anything else is secondary and is a slow path if necessary. And we've done that with all of our methods, and that's paid off. We keep our perf edge. We're able to cram more features in. We're able to cram more bug fixes in. And it's a win for usage and a win for devs. Cool. Is someone talking?
Nope.
No, we're just making sure nobody has any questions.
Oh, okay, cool.
So,
yeah.
Well, we appreciate you hanging out and sharing some stuff about Lodash with us.
Yeah. Rock on.
All right. Well, thank you.
Thank you.
We can go.
Cool. Awesome. Hey, any requests for methods? I have some questions then. So, um, what is y'all's favorite utility method, or what is the method that you think, if it's not in Lodash, you would like to see in Lodash?
I have one. I'd like to see some convenience functions around promise aggregation and things like reduce.
Oh, okay. So
I find myself doing that a lot to do like promise composition, like composing thens on like a large thing. So like you might map an operation on objects to promises. So like you have like 20 elements, you end up mapping those down to objects to maybe go like grab other data, and then you need to aggregate those and do kind of like an all at the end or something like that, or something along that line. Basically a big then after all of those is finished, and you end up writing the same reduce statement all the time, and it just feels like there's a convenience function that would be nice.
you may be able to use composition to create a generic form of that. We're improving the ability to do that with Lodash 3.0, with placeholders, with something called rearg. It allows you to swap the argument order of functions. So you should be able to create a generic version of that. So basically, there's libraries like Ramda.js that came out that's like, hey, we're super functional, and I don't want devs to like abandon ship just because of an argument order dispute, like of a function. I think that's goofy. So we should be able to address that. So in the next release, we'll have something that allows you to switch the argument orders to make composition easier. We'll have things like curry right, so you can fill things in from the right side of the function. So that should make creating generic versions of these commonly used things easier. To async things, though, we probably won't be doing that just yet, just because that's specialized in its own. Like, there's a whole library for doing that. But it's something to keep an eye on. I mean, earlier I wouldn't have done all this functional stuff, but like underscore is billed in several places as the functional lib. I just wanted utility methods, and functional was a plus. But I'm adding more to make that easier for devs. So that's cool. What's your biggest complaint? Like, if you're using Lodash, like, what's the big, like, ugh, this is gross?
Here's a question. Is anybody here using Lodash on a regular basis? Project. So my hand is up. This is where you use it, and it's up here. I don't know that I have any complaints.
Oh, cool. All right, well, hey, if y'all aren't using it, y'all should totally check it out. Yeah, no, that's cool. Like, seriously. Also, so I'm on Twitter too. So @JDalton. And I also monitor any mention of Lodash on Twitter. To probably levels I shouldn't, but if you mention it and you have a question, I'm right there, and I will jump in and help you solve it. Feel free to post questions to our issue tracker. I know some people are like snobby about that and say, hey, use Stack Overflow. I've got a tag in our issue tracker called question, and if you have a question and you can't reach me, like, post it there. You'll get a reply there too. So I try to make it pretty easy. Initially, our build and stuff can be a little intimidating, and you may not know our style guide and all of that, but don't worry about it. Like, give the contributing text a glance, and then just do a pull request. Our style is to accept the pull request and then clean up later. We're not going to nitpick you on, oh, you missed a space in this parenthesis, or you used a double quote instead of a single quote, or you didn't have a semicolon. We're not going to do that. We'll merge it in, we'll clean it up, and just get your code into the code base. We do require a CLA because we're part of the Dojo Foundation, but it's an easy online form you fill out once and you're good for all Dojo Foundation projects. So that means grunt, Require.js, Lodash, and lots of other projects that are under the Dojo Foundation. Once you do the sign it once, you're able to contribute to all of them. So that's pretty cool. But awesome. Thanks for having me and let me ramble on about Lodash for an hour. So cool.
Thanks a lot.
Thanks. Thank you.
Yeah.
Take care.